There is this massive, almost overwhelming expectation right now that artificial intelligence is just, well, it's all about total hands-off automation.
Oh, absolutely. The whole myth of the magic
What?
button.
It's the dream that gets sold constantly. Like you just push a single button, you step back, and the machine just completely takes the wheel.
Yeah, it writes your code, it drafts your
He
reports.
analyzes your data, all of it, and you just get to, I don't know, go grab a coffee while the software runs the entire show.
Which is an incredibly appealing narrative for, marketing materials.
Hmm.
But it rarely reflects how high stakes professional systems are actually built to operate under the hood.
Exactly. Which brings us to our mission for today's deep dive. We are looking straight at the actual code architecture of the SYRAG Core.
The raw source material.
Yeah, specifically, we are going to unpack the prompt tab because we want to understand exactly what it does, what it does not do, and most importantly, why it was engineered this way.
Right. And for you listening, if you're someone who wants to genuinely understand your tools, without the glossy marketing stuff, you're really going to appreciate this transparent, code-grounded look at the system.
Totally. Because looking directly at the source files, files like mainwindow.py and ipromptengineering.py.
That tells the true story of the system's operational intent.
It really does.
I mean, you can read a feature list all day long, but the underlying code architecture reveals what the developers actually prioritize.
And here is the real hook for you today. Well, everyone out there assumes AI integration is about creating that hands-off automated assembly line we just talked about.
Everyone thinks it is.
Right. The real secret weapon in the SYRAG Core architecture is actually strict, deliberate manual control.
It completely flips the conventional AI narrative. When we examine the architecture, the priority is clearly governance over reckless speed.
Okay, so let's unpack this. To truly understand how to use the prompt tab effectively, we first have to understand where it lives in the overall software architecture, right?
Exactly.
Because it isn't just a hidden settings menu or like a side feature you occasionally click on.
Not at all. In the code base, specifically when we look at how the main interface is constructed in mainwindow.py, the prompt tab is instantiated directly into the core layout.
That's right there.
It is mounted as a first-class citizen in the user interface. It hasn't been relegated to being some external plugin you have to download.
Or like some experimental add-on that you have to toggle on.
Right, exactly.
It occupies prime real estate right at the main table. But we have to be incredibly clear about its true purpose, because this is where users often get tripped up.
Oh, constantly.
Yeah. The prompt tab is a prompt engineering workspace specifically designed for reusable R templates.
RAG, meaning retrieval augmented generation.
Right. And that distinction is the foundation of the entire system.
We really need to immediately debunk the assumption that this tab is a direct publishing panel.
Oh, yeah. Like, you do not use this interface to fire off a quick social media post or automatically broadcast a daily newsletter to your clients.
No, not at all.
Let me put it this way. The prompt tab is like the test kitchen, where you painstakingly perfect a master recipe, rather than the dining room where you actually serve the final meal to your guests.
Oh, that's a great analogy.
Right. In the test kitchen, you're measuring the ingredients down to the gram, you're tweaking the spices, constantly adjusting the oven temperature. You're doing the foundational behind-the-scenes work.
That analogy perfectly captures the mechanism at play here. If we connect this to the bigger picture, this architectural choice establishes a governed, standardized process.
A governed process.
Right. Think about a highly technical environment, say like a legal firm or a financial auditing team.
High-stakes stuff.
Exactly. You cannot afford a chaotic free-for-all where every single employee is just guessing at how to instruct the language model on the fly.
Just typing whatever comes to mind.
Right. So by treating prompt engineering as a dedicated first-class workspace, the software forces you to create a standard. It establishes an auditable trail of exactly how your organization communicates with its AI models.
But, a test kitchen is useless if you just invent a 5-star recipe, write it on a paper napkin, and then accidentally throw it away.
Yeah, that would defeat the purpose.
So if we are doing all this painstaking work to create master templates, the system obviously needs a sophisticated way to store them.
And it does. The user experience of this tab is deeply intertwined with its underlying storage mechanism. When you open it up, the interface is built around a dual-pane design.
Which makes total visual sense, honestly. You aren't just staring at a massive blank text box.
No, it's a very deliberate layout. On one side, you have the active editor zone. This is your workbench for writing, refining, testing the variables of your templates.
And on the other side.
Right next to it, you have a searchable, sortable library for retrieval and maintenance.
Ah.
So you can be actively drafting a new instruction while keeping your entire historical library visible for reference.
Wait, hold on, though. Most AI prompt boxes you see on the internet, they just vanish the second you close the app or hit refresh, right?
Basically, yes.
So building an entire local SQLite database just to track text tags and usage, that sounds like massive overkill. Like, why bloat the desktop software just to save what is essentially a text box?
It sounds like bloat until you realize that in a professional workflow, a prompt isn't just disposable text.
Okay.
It is an operational asset. This highlights the exact difference between ephemeral prompt drafting, which is basically throwing words at an AI to see what sticks.
Or throwing text at the wall. I mean, we've all certainly done that.
Oh, we all have.
Yeah.
But the architecture here actively discourages it. If we look under the hood at iPromptEngineering.py, the storage manager isn't just saving a raw text file to your hard drive.
Right. It's doing a lot more.
It persists these templates with highly granular metadata.
Granular how?
We are talking about tracking the name of the prompt, its broad category, the specific industry sector it belongs to,
Wow.
the defined variables within the text, custom tags, the number of times it has been used, and even user-assigned quality ratings.
Wait, user ratings? That is a ton of data for a single instruction.
Because it treats that instruction as the intellectual property of your workflow.
Intellectual property. Wow, yeah.
If your team figures out the exact, nuanced sequence of instructions that yields a flawless, hallucination-free financial summary,
That's gold.
that is an incredibly valuable asset. The SQLite backend ensures that asset is preserved, categorized, and measurable over time.
So you don't have to guess.
Right. You can actually run a query to see which prompts have the highest ratings and the most historical usage.
Which means your entire organization can standardize around the specific prompts that actually work rather than reinventing the wheel every single Tuesday.
Exactly.
But okay, let's say I have a database of like 500 or 1,000 highly detailed prompts. I am going to drown in my own assets.
It could get overwhelming, yeah.
So how does the system make sure I am seeing the right tools at the right time without me having to manually dig through a massive list?
That exact friction is solved by a concept called sector awareness. It is a brilliant piece of cross-component system architecture.
Here's where it gets really interesting for you guys listening. This is where we get into how different parts of the software actually talk to each other.
Specifically through signal wiring within the main window.
Okay, signal wiring.
Yeah. The prompt tab does not exist in a vacuum. It acts as a subscriber, constantly listening to sector changes being broadcast from the configuration tab.
It reminds me of using an IDE, an integrated development environment for programming.
Oh, that's a good comparison.
Like if I open up a Python project, my workspace instantly swaps out all my tools. The syntax highlighting changes, the C++ compilers hide themselves, and the environment adapts completely to the Python language so I don't accidentally mix up my syntax.
That is the exact mechanism.
Really?
Yes.
Mm-hmm.
When you change the sector in your global configuration, say moving from a marketing workflow to a legal compliance workflow,
Right.
the main window broadcasts a state change. The prompt tab catches that signal instantly.
And then what does it do?
It queries the SQL database, updates its internal context, and completely refreshes the dual-pane library to only show templates tagged for that specific sector.
So the system is actively filtering the UI based on my current operational context. I am not scrolling through punchy copywriting prompts when I'm trying to do heavy data analysis.
Exactly. Furthermore, maintaining these strict domain-aware boundaries prevents cross-contamination.
Cross-contamination. Explain how that happens in an AI context.
Well, language models are hypersensitive to the context window you provide them.
Right.
If you are rushing and you accidentally load a prompt template designed for creative, open-ended brainstorming while you are actually trying to parse strict healthcare compliance regulations.
Oh, boy.
Yeah, the output isn't just going to be slightly off. It will be fundamentally flawed and potentially hallucinated.
Because you fed it the wrong vibe, essentially.
Exactly. By synchronizing the prompt library directly to the active configuration sector, the architecture enforces a hard boundary. It keeps the user focused and the operations accurate.
It basically protects you from the clutter of your own workspace.
Precisely.
So we have the context securely set, and the library is perfectly organized, but, a vault of organized prompts is useless if the prompts themselves are poorly written.
Very true.
How does the system actually help you write a better instruction without just taking over the steering wheel?
This is where the system introduces AI acceleration, but it does so with a very deliberate restrictive leash.
A restrictive leash. I like that.
If we look at a file called llminterface.py, the tab supports two explicit computational actions: generating a completely new prompt template from a rough idea and optimizing an existing clunky prompt to make it more effective for the model.
But the way it handles these actions computationally is crucial, right? Because if I click optimize and the AI takes 30 seconds to rewrite my text.
Right, you don't want to just sit there.
Exactly. I don't want my entire software freezing up while I wait.
The architecture prevents that by utilizing background worker threads.
Okay, background threads.
When you request an AI optimization, the action is handed off from the main user interface thread to a secondary process.
So the UI event loop keeps running.
Yes. The interface stays perfectly responsive. You can continue scrolling your library, adjusting tags, or opening other templates while the language model does the heavy lifting in the background. It is a fully asynchronous design.
Okay, and when that background thread finally finishes its work and gets a response from the AI.
The output is cleanly routed back and written directly into the editor pane.
Okay.
But here is the critical architectural decision. It is written there explicitly for human review. It does not auto-execute.
Wait, let me push back on this for a second. If the whole point of utilizing these incredibly advanced language models is speed and automation,
Which everyone thinks it is.
right, isn't forcing me to generate a text, read it with my own eyes, manually edit it, and then explicitly copy it, doesn't that feel like a massive step backward?
This raises an important question, and it's tempting to view it that way if your primary experience is with consumer-grade chatbots. But in enterprise architecture, this is absolutely not a limitation. It is a vital, intentional governance policy.
A governance policy. Walk me through the logic of that.
When you are building systems for risk-sensitive environments, whether that is parsing legal contracts, auditing server logs, or managing financial data.
Right, where mistakes actually matter.
Exactly. The cost of an AI hallucination is incredibly high. If you automate the execution of a newly generated prompt without reviewing its exact phrasing, you are flying blind.
That makes sense.
Now, the architecture actually does contain a signal path, a handoff handler in main.window.p that can technically push a prompt directly to an execution function.
Okay, so it can do it, but the default heavily preferred workflow is manual.
Yes, because manual control drastically reduces accidental execution risk. Once a language model fires off a poorly phrased instruction to an external database or an API, you cannot always put the toothpaste back in the tube.
The damage is done.
Right. The damage is done. This system treats the AI as an accelerator, not the final decision maker. It gets you from a blank screen to a 90% perfect template in 3 seconds.
But you have to finish it.
You, the human operator, must apply the final 10% of domain expertise. You maintain total authority over the text before it ever touches your live data.
Okay, let's go back to that kitchen analogy. It is like having an incredibly fast sous chef in that test kitchen.
Oh, exactly.
They can chop all the vegetables, prep the ingredients, and mix the sauces in record time.
But the head chef still tastes everything.
Exactly. The head chef tastes everything and signs off before that dish ever goes on the dining room menu.
That dynamic is exactly what the code enforces. Speed through AI assistance, safety through human verification.
Which makes profound sense for professional tools. But to truly master this workflow, you have to ensure you're actually using the right tool for the right job, right?
Definitely.
And looking at the source documentation, we really need to clear up a frequent point of confusion regarding how the prompt tab relates to the other interfaces in this SYRAG system.
This is a major stumbling block for users who are trying to understand the broader architecture. There are other interfaces in the system.
Like which ones?
Specifically the Procedures tab, which is governed by a file called iprocedures.py. That tab also features large text fields for LLM prompts.
Right. You open the software, you click the Procedures tab, you see a massive box asking for a prompt, and it is incredibly easy to think, oh, this is just another place to write my templates.
But from an architectural standpoint, they serve entirely different isolated roles.
Okay, break that down for us.
The prompt fields inside the Procedures tab are wired for operational document output. That is the dining room.
The dining room.
Yes, that is where you go when you need the system to read a specific set of active documents and generate a final client-ready report or an immediate data summary.
So the distinction comes down to the final product. Let me synthesize this for everyone listening. If you are trying to generate a final polished document right now, like the actual meal you are going to serve,
Right.
you need to be in the Procedures tab. But if you are building the master blueprint for how the system should generate those reports in the future, the recipe itself, you belong in prompt engineering.
Exactly. Keeping our terminology precise reflects a precise workflow.
Yeah, that makes sense.
You do not design reusable templates in the Procedures tab because it lacks the SQLite persistence and metadata tracking.
It won't save it the same way.
Right. And you do not attempt to generate final operational reports in the Prompt tab because it is sandboxed as a design layer. The code strictly enforces these boundaries.
It is a system built for professionals who value structural rigor over reckless, unverified speed. I think that is the most crucial takeaway from analyzing the source files.
The intent of the software is undeniable when you look at how it routes its data.
All right, let's pull all of these architectural threads together into a clear summary.
Sounds good.
We have seen that the Prompt tab is not a tacked-on afterthought. It is a first-class, natively instantiated workspace.
Built right into the core.
Yep. It relies on a local SQLite database to elevate your prompts from disposable text into highly tracked, valuable operational assets.
With all that granular metadata.
Exactly. And it uses signal wiring to remain sector-aware, constantly filtering your library to match your current domain and prevent context contamination.
Keeping the boundaries strict.
And most importantly, while it leverages background worker threads to give you powerful AI drafting assistance without freezing your interface, its core philosophy demands explicit human review.
Always.
It gives you the raw speed of artificial intelligence, but it permanently keeps your hands firmly on the steering wheel.
And, if we step back and look closely at what that local scallop persistence really implies for the future, it leaves us with a fascinating broader concept to consider.
Yeah, where does the code point us?
Think about the metadata fields we discussed. Because this system actively tracks variables like usage counts and user ratings for every single template.
Yeah.
We are moving far beyond just saving paragraphs of text. We are actually mathematically quantifying the value of our instructions.
Oh, wow.
As these localized databases grow across organizations, we will be able to empirically prove which specific combinations of human words consistently generate the most successful AI outputs.
That's wild. We are tracking the performance of sentences the same way we track the performance of an algorithm.
Exactly. It forces us to ask, how might tracking this historical performance fundamentally alter how we value human language?
Seriously.
Are we rapidly approaching a workflow where carefully crafted, highly rated English sentences are managed, version controlled, and prized in the exact same way we currently value highly optimized machine code?
Human language literally transforming into governed, reusable code. That is an incredibly powerful framework to view this through.
It really changes how you look at a simple text box.
It does. Thank you so much for guiding us through this source files today.
My pleasure.
And to you listening, we hope this transparent, technical look under the hood helps you command your AI tools with a much deeper level of confidence. Keep questioning how your systems are wired, keep exploring the architecture beneath your workflows, and we will catch you on the next deep dive.